All right, so what we're going to do is we're going to cover topics from the Algebra 2 curriculum, and it's going to help us prepare for the Regents, and we're going to go through them unit by unit. All right, so let's start with Unit 1. So if you flip the page in your packet, you'll see that Unit 1, it says on the bottom, page 3. All right, so Unit 1 really just deals with factoring. So with all of these questions, we're just going to factor. So with number 1, it says, when factored completely, and they give us this expression, they want to know what is it equivalent to. All right, so if you remember, our first step in factoring is, can I pull out a greatest common factor? So if you look at all 3 of these terms, right, they all contain an m. So let's first pull out an m. All right, I guess I'm going to do that right down here. And when we pull out an m, that's going to leave us with, well, we had m to the 5th, and we pulled one of them out, so we're still going to have m to the 4th. And then plus, well, if we take an m out of m to the 3rd, that still leaves us with 2 of them being multiplied together. So we write that as m squared. And I'll bring down the minus. And we had a 6m, but we took the m out. So we're going to take this 6 and bring it down. All right, so now we want to look and see what we have in the parentheses. So we have a trinomial, 3 terms. And whenever the leading coefficient of a trinomial is a 1, what we do is we set up 2 sets of parentheses. And don't forget about this m on the outside. We got to bring that down, right? That's part of our expression. And then I'm just going to take the square root of this term. So I want to say what times itself gives you m to the 4th. So m squared. So that's what I'm going to put here and here. And then from here, right, this is just whenever the leading coefficient is a 1, it's the a-m method. So let me put an a here and an m here. Okay, so we're coming up with 2 numbers that multiply to -6 and add to, well, there's really here, you could put it in there if you want. There's really a positive 1 in here and add to positive 1. Okay, so those 2 numbers would be positive 3 and negative 2. Right? Those are 2 numbers that add to 1 and at the same time multiply to -6. Now, whenever you have 2 terms in the parentheses, a binomial, you want to look and say, do I have a difference? Well, no, but yes, right here, of perfect squares. But 2 is not a perfect square, so we can't factor this further. So this right here is completely factored. And you can see that that matches up with, right there, choice 4. Okay, number 2 wants to know which expression is equivalent to this given expression right here. Okay, now some of you may look at this and say, well, I see terms in front of parentheses, so let me try to distribute and see what I get. So if you did, right, we would have, let me just work with this, x to the 6th, y to the 4th times x to the 4th would give us x to the 10th, remember you add the exponents, times y to the 4th, which is what this says, x to the 10th minus y to the 4th. Okay, and then if I distribute this to the -16, I'll have -16 x to the 6, y to the 4th, which is what that says. All right, so far choice 1 is looking good. Then if I distribute the -9, I get -9 x to the 4th, which is what this says, so here we go. But this is where we're running into a problem. Isn't -9 times -16 positive 144? And this says -144. Okay, so choice 1 is not the answer. If we try to distribute that out, that's not going to work out for us. All right, let me get rid of this here. Now, what you may notice, and this is, I think, very, very important. See how this and this say the exact same thing within the parentheses? Well, whenever you have 2 of the same terms in the parentheses, isn't that the middle step of factor by grouping? Right? Can't you take what's in front of the 2 common parentheses and group them together as a factor? So I could take the x to the 6th, y to the 4th, and the -9. Okay, so I'm taking what's in front of these and grouping them together. And then you can rewrite that common parenthesis. And there we go. Okay, now from here we want to look and say, look, we have a binomial and another binomial. Do we have a difference? Yes, they're both difference of perfect squares. So let's look at this first one. Right here, right, as long as your exponents are even, they're perfect squares. And then we know 9 is a perfect square, right? Because 3 times 3 gives us 9. So we could take this first parenthesis and break it up into 2 separate parentheses. And since the square root of x to the 6, y to the 4th, is x cubed, y squared, let's put that in the first spot in each parenthesis. Okay, we know we're going to have 1 plus and 1 minus. And then the square root of 9 is 3. So let's put a 3. Okay, before I move on over here, just to point out, neither one of these can factor further. Even though this one's a difference, we don't have perfect squares. So over here, these two factors are as far as we're going to go. Now, if we look here, let's see, we have a difference. And these, again, are both perfect squares. Okay, this has an even exponent. And then the square root of 16 is just 4. So let's break that up into 2 more parentheses. Okay, we know the square root of the first term is x squared. We're going to have 1 plus and 1 minus, and the square root of 16 is 4. Okay, now you may notice, look at this, we have another difference of perfect squares. So we could factor this one further. If I were to factor this one further, this would break down into x plus 2 and x minus 2, because the square root of the first term is x, so we put that first. The square root of the second term is 2, so we put that second, and we make 1 plus and 1 minus, and then we're just going to bring everything else down. Okay, so this right here is fully factored. That was a lot of factoring going on. Now, if we look at the answer choices, none of them actually say exactly this, right? Which is okay, because they didn't want us to completely factor this. They just said which is equivalent. So we have to go through and look at this. So let's start with choice 2. Here we go. We have x to the 6th, y to the 4th, minus 9, which we have here. And then let's see, if we factor this further, does it leave us with x plus 2 cubed times x minus 2? Nope. Okay, so that one's not our answer. All right, so let's look at choice 3. Okay, so we have our x cubed y squared plus 3 and our x cubed y squared minus 3, which we see here and here. But then this says x plus 2 squared and x minus 2 squared. All right, we don't wind up with a square in each one of those. So choice 3 is out as well. So if we take a look at choice 4, we can see that we have our first 2 parentheses here, which match up. And then we have our x squared plus 4, which we have here. And here's the x squared minus 4. Okay, look, that's the same term that we had in this second step here. Okay, they just didn't factor it further, but we don't have to. They just wanted to know which is equivalent, not which one is factored completely. So choice 4 is our answer. All right, so if we take a look at number 3, now number 3 starts us off with 6 terms. Okay, and when you start off with 6 terms, don't try to combine the like terms or rearrange them. What you want to do is we're going to do factor by grouping. We want to look and we want to say, all right, we're either going to group this into 2 groups of 3, like that, or we're going to group it into 3 groups of 2. And you want to try to look ahead just so that you don't waste your time, grouping it incorrectly. So if you look, I'm looking here. If I were to group together these first 2 terms, okay, see how the exponents go 4 and then 2? Okay, so isn't this 4 2 bigger than the 2? All right, let's look at our next terms. So the next 2 terms, the exponents, we have a 3 and a 1. And isn't this exponent of a 3 2 bigger than the exponent of a 1? Okay, and then if we look at our last 2 terms, right, look at this exponent. We have a 2 and then a 0. So if we group it into 3 groups of 2, the exponents are going to work out nicely for us. All right, so let's do it. So I'm going to group together. And you know what? If you can't look at it and do that, no big deal. Try grouping it into 2 groups of 3. And if that doesn't work, then try grouping it into 3 groups of 2. What we're looking for is to wind up with the same expressions within the parentheses. Okay, so again, out of these 2 terms, right, let's see, I could pull out an n squared. And when I do, in parentheses, it's going to leave me with n squared minus 9. Okay, now out of the next 2 terms, I can pull out a 4 as well as an n. And since this is a plus sign, we're going to pull out a positive 4. as well as an n. And when I do, that's going to leave me with n squared minus, and again, a 9. Okay, so our parentheses are matching up so far, so this is good. Okay, and then out of the last two terms, right, there's no n's that we could pull out, but that's okay because we want to be left with an n squared anyway, right? But here, the biggest number that divides evenly into both of these is a 12. And because this first term is a negative, we're going to pull out a negative 12. Okay, and that's also going to leave us with n squared. And since 108 divided by negative 12 is negative 9, we're going to have minus 9. All right, so we know we're on the right track because these parentheses match up. So what we want to do is we want to take what's in front of the parentheses. So the n squared, the 4n, and the negative 12, and we're going to group them together. So n squared plus 4n minus 12, and that's our first parenthesis. And then we're going to rewrite this common parenthesis once and once only. All right, now we're not done because it says the completely factored form. So we have to completely factor these. So let's look at our first factor here. This is a trinomial. We know if we have a trinomial with a leading coefficient of 1, we don't do the rainbow, right? We don't waste our time on that. We just set up two sets of parentheses. We take the square root of this first term and we put it in the first spot. And then we just do our AM method. We need to come up with two numbers that multiply to negative 12 and add to positive 4. So positive 6 and negative 2. Okay, and then if we look here, right, we have a binomial, two terms. So if you have a binomial, what we're looking for is a difference of perfect squares, which they both are perfect squares. So we could set up two sets of parentheses, and then we're going to take the square root of the first term. So the square root of n squared is n. We're going to make 1 plus and 1 minus, and then we're going to take the square root of the second term. So the square root of 9 is 3. So let's put a 3 in each spot. All right, so this answer, we're looking for the exact answer because they want the completely factored form. I mean, these factors could be in any order, but we're looking for these four factors. All right, and it looks like, I think I see them right here in choice 2, right? We have the n plus 6, the n minus 2, the n plus 3, and the n minus 3. Oop, right there. So choice 2 would be our answer. All right, and then finally, number 4. Now, number 4. If you take a look at this, let me just move this up a little, give myself a little more room. If you notice, right off the bat, I see, look at this. We have an x plus 2 and an x plus 2, the same thing within the parentheses. But on this one, there's a squared. On this one, there's a number in front of it. And this 3 doesn't even have an x plus 2 next to it. So what I'm thinking is, this is kind of set up in our trinomial format. Like if I were to, let's just say, instead of writing x plus 2, let's say I took another variable, a for example, and rewrote this as a squared plus 4a plus 3. Wouldn't that allow me to easily factor it? Okay, because that would just be set up as a trinomial. So whenever you notice that you have the same expression within a parentheses and one has a squared on it or some exponent and the other one doesn't have that same exponent on it, this is where we're going to bring a different variable into play. Okay, I use a, you can use y, you can use whatever you want. But I'm going to let a equal what we see in those parentheses. So I'm going to let a equal x plus 2. So what I can do is, since a is equal to x plus 2, I can replace what's in these parentheses with an a. So I'm going to rewrite this as a squared plus 4a plus 3. And the reason I do that is because now I've created a really easy trinomial to factor. Right? Isn't this just our add multiply method? Okay, so let's set up two sets of parentheses. The square root of a squared is a. And two numbers that multiply to 3 and add to 4 would be 3 and 1. So positive 3, positive 1. Now, we don't see this answer. Actually, look, they try to trick you. See that? They wrote x plus 3 and x plus 1. We don't have x plus 3 and x plus 1. We have a plus 3 and a plus 1. But think about it. The original expression never had any a's. So what we need to do, it had x's, right? We need to go back and switch them back to x's. Now, since a equals x plus 2, wherever we see an a, right, we can replace it with an x plus 2. So I'm going to replace these a's with x plus 2. Now, I need to bring everything else down. So in front of this a, right, we had a parenthesis. So in front of our x plus 2, we're going to have a parenthesis. And then after it, it says plus 3, close parenthesis. So plus 3, close parenthesis. I'm really just bringing everything down. I'm bringing down the x plus 2, bringing down the plus 3. Same thing over here. We replace the a with an x plus 2, and let's just bring down the plus 1. So now if we combine our like terms within the parentheses, isn't 2 plus 3, 5? So we have x plus 5. And isn't 2 plus 1, 3? So we have x plus 3. So this right here would be our answer. And you can see that matches up with, right there, choice 2.